Okay guys, I kind of forgot to do this, so we're going to try to do this. If theta is an angle in quadrant 1 such that 196 over tangent squared of 2 theta is equal to secant squared of theta plus 2 tangent theta, and the sum of all possible values of tangent theta is a over b, where a and b are positive integers, no common factors greater than 1. Okay, secant is secant squared of theta. So secant is 1 over cosine, so it's 1 over x. So if we do, it's going to be x over x plus y over x is equal to r over x. This is 1, so this is 1 plus tangent squared. So 196 over tangent squared of 2 theta is equal to 1 plus tangent squared plus 2 tangent. Now this would be very simple if this wasn't 2 theta, so now we're going to have to find the double angle formula for tangent. And we're going to have to square that. Or, can we turn this into secant? And then maybe that would be easier, that would be easy. If I could do that, I don't know if I can do that. Well, first this is 196 cotangent squared of 2 theta. Okay, that kind of simplifies things. Cotangent squared is the same thing as x over y. So we have x over y plus 1 is equal to r over y. So this is cotangent squared plus 1 is equal to, this is cosecant. So cotangent squared is equal to cosecant squared minus 1. So now we have 196 times cosecant squared of 2 theta minus 1. So cosecant squared is much simpler. Cosecant is 196 times 1 over... Freak, this always messes me up. This is 1 over sine of 2 theta. Sine squared 2 theta minus 1. Sine, it's the same thing as 196 times 1 over sine of 2 theta squared minus 1. Sine of 2 theta is, or sine angle addition is sine A cosine B plus cosine A sine B. So that's going to be sine A cosine A plus sine A cosine A. So 2 sine. So it's 196 times 1 over 2 sine cosine squared minus 1. So 196 times 1 over 4 sine squared cosine squared minus 1. I swear sine squared cosine squared is that anything? I don't know. I could make this in terms of, I want this in tangent. Tangent is related to, this is tangent and this is secant, is related to secant. So I want over x, because I want this to be secant. So I can change this to sine 196 times 1 over 4 times cosine squared minus 1 times cosine squared minus 1. So that's going to be I'm just going to distribute the 196. 196 is going to be 4 times 49. So we have 49 over, then it's going to be cosine to the 4 minus cosine squared minus 196. Okay. Now what do I do here?
What do I do here?
Maybe I don't distribute this, because then I get a addition or subtraction, and then I just do, let me rewrite this, 49 over sine squared cosine squared minus 1. So it's going to be 49 times cosecant squared secant squared minus 1. And then I can change this to cosecant is related to, no, secant is related to tangent. No, 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 no. Yes, tangent is related to secant. So we get 49 times cosecant times secant squared is equal to tangent squared plus 1. So we have tangent squared plus 1 or minus 1. This tangent is the same thing as sine times secant. It's the same thing as it's something that's sine over cosine. Cosecant is huh. I just have this pesky cosecant that I can't get rid of unless I have a vision. I have a vision. Cosecant is... Never mind, I don't have a vision. I do have a vision. 49 times cosecant is 1 over sine squared times tangent squared plus 1 minus 1. Tangent squared, this is 1 plus cosine squared, but can I turn that into tangent at all? Yeah. Or 1 minus. Would be 1 minus cosine squared. What do I do? Wait a minute. Let me distribute this. We get 49 times tangent squared over sine squared plus 49 times 1 over sine squared minus 1, but this just cancels out to 1 over cosine. And then we're just back to this. Let's say tangent is equal to x, then we have here 1 plus x squared plus 2x, and then here we have 49 times 1 over sine squared, they're just cosecant squared, times x squared plus 1 minus 1. Add 1 to both sides, because why not? Then we just get, right now we have 49 times cosecant squared is equal, or times cosecant squared times x squared plus 1 is equal to 2 plus x squared plus 2x. Okay. Does cotangent relate at all to tangent? No, it doesn't. Because it has different asymptotes, it doesn't at all. Maybe cosine can't relate to tangent. I'm not sure. I am not sure. Maybe. We're looking for the values of tangent of theta. We're looking for the values of x. Maybe it's worth just going and replacing everything with x and y, and then I can solve for x and y. Because, like, once I'm here, I can do that, I think, safely. Or here, I think. Let's do 49 times 1 over x squared y squared minus 1. That's equal to 49 over x squared y squared minus 1 is equal to 1 over x squared plus 2y squared over x squared. So why don't we just multiply by x squared, eliminate x squared from everything. So now, just multiply by y squared. We get 49 minus y squared, or no, I could just add 1 to both sides. 49 is equal to 2y squared plus y to the 4. So 0 is equal to y to the 4 plus 2y squared plus 49. And then just solve this like a quadratic. We get 0 is equal to y freak. We can't solve this like a quadratic because there are no. No, that's minus 49. It's fine. One's positive, one's negative. 49 is 7 times 7. That's a freak. Nothing. the sum of the solutions of this is 2. We know. The sum of the solutions of this is 2. But no, we actually have to solve. Y is equal to negative 2 plus or minus the square root of 4 minus 4 times A is 1 and then 49 all over 2. Take out these two 4's, this turns to 1, this goes to negative 1, we get y is equal to negative 1 plus or minus the square root of 1 plus 49, so 50. 1 plus or minus root 50 over 2. No, just 1 plus or minus root 50. So that's, or negative 1 plus or minus 5 root 2. Negative 1 plus or minus 5 root 2. Negative 1 plus or minus 5 root 2. Quadrant 1, so y is positive. So it's going to be negative 1 plus 5 root 2. Y is equal to negative 1 plus or minus 5, no, plus 5 root 2. And then x squared is equal to 1 minus y squared. So x squared is equal to, man, I'm writing this in a different color. 1 minus negative 1 plus 5 root 2 squared is equal to 1 minus, it's going to be 1. That's going to be minus 50 times 2, minus 100. No. It's this times this, plus this times this is 10 root 2. Then plus 50. We get, these two cancel out. 50 minus 10 root 2. A over b. The value of tangent of theta is y over x. So we get negative 1 plus 5 root 2 over, shoot, 50 minus 10 root 2. This is negative 1 plus 5 root 2 over 10 times 5 minus negative 10 times, no, this is going to be negative 1 minus 5 root 2 over 10 minus 10 times 5 minus 1 root 2. Complex conjugate time, I think. Negative 1 plus 5 root 2 over 50 minus 10 root 2 times 50 plus 10 root 2. That's just going to be 50 squared minus... Why am I doing a complex conjugate, bro? It's going to be 50 minus 200, 550 squared minus 200, which is not going to be the correct answer. Because it's going to involve a square root, and that's incorrect. I got it wrong. Let me check. Okay, what they did is they substituted secant in, which I did correctly. So they substituted tangent in there, and then they realized that, hey, sure you do, and okay, 2 plus 2 tangent plus tangent squared is equal to 1 plus tangent squared. Then they multiplied by this, then they took the square root, so they said plus or minus 14 is equal to tangent of 2 theta times 1 plus tangent of theta. And then there were like, they did something, I don't know. They're like tangent isn't equal to negative 1, so they divided that out somehow, which I didn't know you could do, but yeah, cool. I didn't get it right. Thank you guys for watching, I'll see you guys tomorrow, bye.